In this tutorial, we're going to talk about dilutions. Dilutions is basically you're going from something that's more concentrated to less concentrated. Now, if you look at this, what do you notice about the number of particles in both beakers? You should say that they are the same. There are 13 in here and 13 in here. Now, let's say that each of these yellow particles are moles, so there are 13 moles in each beaker. Now, the main difference between the two is that the volume are different. So the main thing is that one has a larger volume. So in order to make a definition, dilute is to make a solution less concentrated by adding more solvent. So here we have a certain volume of solvent and we've added more. So if I write a line, they would be the same here, but now we've added more, so you're just adding more solvent. And in the dilutions, the amount of the solute remains constant. So 13 moles and 13 moles, but the key thing was this had a larger volume. And if you have a larger volume, that means your concentration is going to be smaller. Dilutions basically reduce the ratio of moles of solute to liters of solvent. And so the key thing here that you need to know is that the number of moles before the dilution are the same number of moles after. Again, 13 moles. 13 moles. That does not change. The key thing that changes is the volume. So that's what the key difference is for dilutions and when we do dilution calculations. And the key use of dilutions are in a laboratory setting. Let's say that you have a higher concentration of a solution. Let's say you have 6 molar solution of sodium chloride and you need 3 molars of sodium chloride. You need to make a dilution. So you need to make a dilution from the original solution. That's called, if it's original, that's called the stock solution because that's your original solution that you're diluting. And now there are 3 things that you really should know. And the first thing you need to know is the initial volume and initial concentration. So here are your initial volume and initial concentration. The next thing you need to know is either, so here's the key thing, it's either the final concentration or the final volume. So the 3 information are always going to be initial, and then you have to know one of the final values. Now that you know that the 3 pieces of information that you need to know, again, here's the whole idea of initial moles is equal to the final number of moles. And so there's a reason to this. You also have to know that your initial volume will never equal your final volume. If that's the case, then your concentrations should stay the same. So when we're doing dilutions, you can actually put it into an equation. And when we do it in an equation, you have the initial concentration times the initial volume and times, it's equal to the final concentration times the final volume. And let's just make life easy. And let's go ahead and write this down. And concentration we're going to represent as capital M for molarity. So M1, V1, this is your initial, and M2, V2 are your final. Okay. Now, how do we get to this? You're going to ask, why is that, and how did we get this formula? And the reason why we get this formula is because if we do a derivation, you will realize that if we put our units, so moles over liter for the first molarity or concentration, times volume 1, which is in units of liter, it's equal to, again, molarity, which is mole over liter, times volume 2, which is again liter. And you end up canceling out the units. And so we should end up with your initial number of moles equals your final number of moles. So that's how we derive this equation. M1V1 is equal to M2V2. Now there are several types of problems you might encounter, but in general, these the next two sample problems are what you're going to encounter, and you typically will have the initial concentration, initial volume, and you will be given a final concentration or a final volume. So in this case, we have the numbers. So if we read this, how many milliliters of a stock solution of 12 molar would you need to prepare 100 milliliters of 1.00 molar HCl? Now, if you read this question, you'd think, hey, this 100 milliliters is not our initial, it's actually our final volume. So I'll just go ahead and write what's given. So we would say our final volume and final concentration are 1.00 molar, and our final volume is final volume is 100 milliliters. Now, when we were calculating concentration, we had to convert milliliters to liters, but in dilution samples, we do not, unless I'm asking you to solve it for it in liters. But in this case, we do not, because we are looking for our final volume or initial volume to be in milliliters, so we don't have to change that. We also know that our stock solution, so this is our initial, so our M1 is equal to 12.0 molar. Now, we are looking for how much of this we needed to make this. So we're looking for V1. Let's go ahead and write our equation. M1 V1 equals M2 V2. And we're looking for V1, so we're looking for this. If we want to isolate this on its own, we'd have to divide both sides by M1. And so V1 is equal to M2 V2 divided by M1. And you just plug in the numbers. So 1.00 molar times 100 milliliters divided by 12.0 molar. And if we do our cancellation of units, we should cancel out capital M, and we're left with milliliters. So our final answer should have milliliters. And our final answer, 8.33 milliliters. So we have to get 8.33 milliliters of our stock solution and dilute it to 100 milliliters. Okay. And so if you've noticed, this question's also similar. You have 2.00 molar of magnesium sulfate, and you're looking for how much you need to use in order to make 150 mils of 0.400 molar magnesium sulfate. So let's go ahead and write all our knowns. We know our M2 and V2. We know our M1, and we don't know our V1. So let's go ahead and put a question mark. It's 2.00 molar for M1, and for M2, it is 0.400 molar. For V2, it's 150 milliliters. And again, if you look at this, we do not need to convert milliliters into liters because we are looking for the answer in milliliters. And so again, let's go ahead and put our equation M1V1 equals M2V2. And let's again isolate this V1, and you should end up with V1 is equal to M2 times V2 divided by M1. And we can go ahead and plug in our numbers. 0.400 molar times 150 milliliters divided by 2.0 molar. And again, if we cancel out the units, we cancel out the capital M's when we're left with milliliters, which we are looking for as a unit. And our final answer should be, 30 milliliters. Again, and that is our final answer. 30 milliliters of the 2.00 molar solution of magnesium sulfate are required to make the 150 milliliters of 0.400 molar magnesium sulfate. And this is the third video of the installment. So go ahead and move on to the next video for calculating titrations or calculating pHs.